Good evening, guys. Is my screen visible?
Yes, sir.
Okay. So yesterday we were discussing these problems, right? So problems based on conditional probability. So we completed example number 4, 5. We have completed till example number 5, right? We are supposed to start with example 6. Shall we get started? So tell me how to solve this problem. A die is thrown twice. Right? A die is thrown twice and the sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? So how to start solving? So what is going to be the sample space? The sample space contains how many elements? It contains 36 elements. Reason? 6 square. Right. And the sum of the numbers appearing is found to be 6. So how to, what should I take that as?
Sir, 1,3, 3,
So I'll call that E.
oh, sorry,
matrix.
1,5, 5,1.
So how should I take the, see, what is, this is the problem based on conditional probability. I'm able to understand. So for me to apply the conditional probability, I need to write probability of E given F. So which one should I take it as E and which one should I take it as F?
Sir, the sum is 6 as E.
See, a die is thrown twice and the sum of the numbers appearing is observed to be 6. Means this is something that has already occurred. So something that has already occurred should be taken as F. And I told you, no, they asked what is the probability that. So after that, after the word that, there is a statement, right? The number 4 has appeared at least once. That is there, no? So that should be taken as E. So what is F? F is 1, 5, 5, 1. Then 2, 4, 4, 2. Then 3, 3. And we are done. So what about E? That the number 4 has appeared at least once. So where can 4 appear? 4, 1, 4, 2, 4, 3, 4, 4. Can I take 4, 4? They used at least once, no? Can I use 4, 4?
Yes.
Yes. So when should I not use 4, 4? What should be the word that I should not use 4, 4?
Exactly.
They use the word at most. Or exactly. So 4, 5 and 4, 6. Then what will happen? Exactly write it in the reverse. 1, 4, 2, 4, 3, 4. What should I avoid? 4, 4 I should avoid. And that's it. So what is the probability of E given F? That is going to be probability of E intersection F divided by probability of F. So what is the probability of E intersection F? 2, 4, 2, 4, 4, 2, 4, 2. So it is 2 out of 36 divided by, what is the probability of F? 1, 2, 3, 4, 5. So 5 out of 36. So it will get cancelled. Answer will be 2 by 5. So 36 is lost. Answer will be 2 by 5. Is that point clear?
Yes, sir.
So are you guys clear with which one to be taken as E and which one to be taken as F? So that's what you need to master for conditional probability. If you crack that, this chapter is easy. Right. Shall I proceed? Okay. So do this. Consider the experiment of tossing a coin. So sample space is going to be head, tail. If the coin shows head, then toss it again. But if it shows tail, then throw a die. It's a good one. Right. So this is not the sample space then. So a coin is tossed once. So sample space will be, if I get a head, what am I supposed to do? Then toss it again. So there is a possibility we'll get head, tail. Right. Whereas if you get a tail, what are you supposed to do? You need to roll a die. So when you roll a die, you'll get tail, 1, tail, 2, tail 3, tail 4, tail 5, and tail 6. Is that right?
Sir.
Tell me.
Sir, in this, suppose first we toss a coin and we get a head, sir, and we again toss the coin and get a tail. So we have to toss the die again.
No. That's it. If you get a head, then toss it again and leave. So nothing. I'll tell you.
Okay, sir.
Got it? Understood?
Yes, sir. Understood.
Okay. Then what are they asking? The coin is tossed, shows tail, then throw a die. Okay. Find the conditional probability of the event that the die shows a number greater than 4. Given that there is at least one tail. So which one is E and which one is F?
F is the tail one, sir.
So F is the die shows a number greater than 4. No.
Sir, but given
So
that,
find the
sir,
conditional no. I'm sorry, it is my mistake. Find the conditional probability that after that you have die shows greater than 4. So E should be greater than 4. So if you need the die to come into picture, what should be the first element? It should be a tail. So T, 5 and T, 6. Am I right? What about
yes.
F? Given that there is at least one tail. So at least one tail means it should be T1, T2, T3. Sorry, it should be head, tail, T1, T2, T3, so on till T6. Am I right? So what is the
Sir,
probability?
sir, but how will head, tail come, sir?
At least one tail. No?
Sir, but even
There
if
is at least-
tail comes, then we are not supposed to throw a dice, as you said, right?
No, but after you get a head, when you throw a die, sorry, when you toss a coin, there is a possibility of you getting a tail. No, they told in that ordered pair that you're taking, there should at least be one tail.
Understood,
is-
sir.
Yeah. So probability of E intersection F divided by probability of F. So what is the probability of E intersection F? T, 5, T, 6. So 2 out of how much? 8. Because 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8 divided by, what is the probability of F? 1, 2, 3, 4, 5, 6, 7. 7 out of 8. So answer will be 7 or 9.
7 only, sir.
7 out of 8. One minute. Probability of E intersection F is going to be how much? Did I miss something? 1 minute. So 2 out of 36 divided by. Okay. So probability of E intersection F should be 2 by 8 divided by 7 by 8. Answer should be 2 by 7. No, here the answer is given as 2 by 9. Okay. Let me check what is the mistake I made. Probability of E and F2 upper. Is greater than 4, even if the number has at least one tail. So 1, 2, 3, 4, 5, 6, 7, 8. Am I missing something? Okay. So you take the probability of X. Okay. Listen, guys. Here, one mistake that happened is the likely value of probability for each outcome is not the same. I'll tell you why is it so. Okay. 1 minute.
Sir, is it because like for the coin it is 1/2 and for the dice?
Yeah,
One
yeah.
by-
Yes. So that is the reason. So what will happen is, see, in this problem, you cannot directly use it because in the previous problem, what happened? See, though it was the ordered pair set, I could directly use E intersection F as 2 by 6 because it was a single object. What was that single object? It was only a die. Whereas in this problem, what is happening? You have a coin and a die, which are going to have different sets of probability. So, like how it is mentioned in the textbook, right? If you're able to draw that classification diagram. See, for example, if a coin is tossed, you getting a head has a probability of half, and you getting a tail has a probability of half. So if you get a head, then again you getting a head here and tail here has a probability of only 25%. You're able to understand why is it so? Because you will get this head and this tail only if you get the first head. Clear? So if you have the probability of tail, then what will happen is you getting the probability of tail comma 1 is going to be 1 by 12. Why is it 1 by 12 is because when you roll a die, what is the probability of getting 1? When you roll a die, what is the probability of getting? It is 1 by 6. Right? But here, before you get this one, what is the condition that needs to get satisfied? You need to get a tail before that. So the probability is going to become 1 by 2 into 1 by 6. Why is it 1 by 2 into 1 by 6? Because I need to get a tail whose probability is half. And in the case of set is multiplication. Guys, are you able to understand what I'm saying?
Yes, sir.
Listen
Yes,
to
sir.
So half into 1 by 6, which is going to be 1 by 12. There's a mistake made. So here it is going to be 1 by 12, 1 by 12, 1 by 12, 1 by 12, 1 by 12. So how much is it going to be? So this is for tail, comma 1. This is for tail, comma 2, T3, T4, T5, and T6. Right? Right. Now, what is the probability of F? So what is first of all F element? Oh, sorry, F set. So F set is equal to, if you see, it is head comma this thing, no? Head comma tail, tail comma 1, tail comma 2, tail comma 3, till tail comma 6. So this is divided as, so probability of F will be probability of getting head comma tail, or probability of getting tail comma 1, or probability of getting tail comma 2, or T3, so on till probability of T6. So what is the probability of getting a head and a tail? Head followed by a tail. It will be 1 by 4 plus 1 by 12 into 1 by 12 multiplied with itself 6 times. So it is going to be 1 by 4 plus half, which is going to be 3 by 4. Am I right? So probability of F is actually 3/4, means 75% chance to happen. Because what are the rejected events? The rejected event is head comma head. So it has 75% probability to happen. So what is probability of E intersection F? That will be probability of probability of getting a t comma 5 or t comma 6. So that will be probability of getting a t comma 5 or probability of getting a t comma 6, which is going to be 1 by 6. Okay. So probability of E given F is equal to probability of E intersection F divided by probability of F. What is the intersection F? 1 by 6. And what is the probability of F? It is 3 by 4. So this cancels 3 times. This is 2 times. So answer should actually be 2 by 9, not 2 by 7. Okay. I repeat, in this problem, why are we doing this kind of a, why are we finding this kind of a solution? It is because the objects used are different. Since each output is not equally likely, we have to go with this method. Okay. So this concept is basically, one thing you need to remember is into is used when you use the word and. Plus is to be used when you use the word or. Okay. So this is an important problem, mark it. Okay. Now 13.1. Shall we start? So tell me what is the answer for the first one. Point 2 divided by 0.3, which is going to be 2 divided by 3. So what is the probability of F given E? That is probability of E intersection F divided by probability of E. E intersection F is again 0.2 divided by probability of E will be 0.6. So 2 by 3, which is going to be 1 by 3.
Sir,
Tell me.
sir, does probability of E given that F plus probability of F given that E added to 1 always?
Not necessarily, but here we are getting it.
So could you give a case where it doesn't add
See,
up?
let's do you yourself do and see. No, let's try to do and see. probability of E given F plus probability of F given E is equal to probability of E intersection F divided by probability of F, right? Plus probability of E intersection F divided by probability of E. Am I right?
Yes, sir.
So what is the LCM you are going to take? Probability of E intersection F will come out. So what are you left out with? Probability of E plus probability of F divided by probability of E into probability of F. Right. When will you say probability of E plus probability of F? That is,
Sure.
if I have probability of E union F, what is it? Probability of E into probability of F minus probability of E intersection F. So had E and F been,
It would be plus, right? In between.
Probability of E plus probability of F.
The probability of E plus probability of F.
that's what I wrote, no?
So you wrote
That-
multiplied.
Where multiply? Denominator.
Sir, in the formula, sir.
No,
P
sir.
of E
In
union.
the formula.
Illada. Here.
No, sir,
Yes.
in the P of E union F. That
The
formula.
top right.
Top
top
right.
right.
Oh,
Corner.
sorry. Yeah. P of E plus P of F minus P of E intersection F. Okay. So here, see, this is one of the cases, okay? Not necessary that every time this is how the values will be.
Okay, sir.
Okay. So what is happening is, suppose I want to get a value of 1 here, then what should happen is this whole thing should cancel this. I need a condition of that sort. So that depends on two parameters. One is called as mutually exclusive events, and the second is called as independent events. So depending on that only it will change. So not always the sum of these two is going to be equal to 1. Not always. For example, if you want, you can take the previous
Okay, sir.
problems and do the experiment and see. Okay. Try and see.
Okay, sir.
So do this, no? So what is the probability of A given B? It is probability of A intersection B divided by probability of B. 3.32 divided by 0.5. It is going to be 3.2 divided by 5.
Sir, if you just multiply into 2, you'll get 0.6.
How much are you getting?
0.6. Sir, 0.5 is 1 by 2.
0.6.
So just multiply. Yes, sir. 0.6.
0.65. I'm not checking.
4, sir. 4.
0.64. Okay. But I have a doubt. When you multiply it in 3.2 by 5, correct, 0.64. Yeah.
Sir, 0.5 is 1 by 2.
No, that's fine. You just take that half and correct. So probability of A is 0.8, probability of B is 0.5. So what is the probability of B given? Probability of B given A is 0.4. So solution. Maybe this problem will give us an answer. So what is the probability of A intersection B? It is probability of A given B into probability of B. Can I write it like this? Or can I write it as probability? See, it's simple, guys. Probability of B given A is equal to probability of A intersection B divided by probability of A. So take it to the other side. Probability of B given A into probability of A is equal to probability of A intersection B. So what is the probability of B given A? It is 0.4 into probability of A is 0.8 is equal to what is the probability of A intersection B? That's the value. So probability of A intersection B is equal to 0.32. So what is the probability of A given B? It is the probability of A intersection B divided by probability of B. So what is the probability of A intersection B? 0.32 divided by probability of B is 0.5, again 0.64. So just now add and see. probability of B given A plus probability of A given B? Is it coming out as 1? No.
Sir.
Similarly, probability of A union B will be probability of A plus probability of B minus probability of A intersection B. So what is the probability of A? 0.8. What is the probability of B? 0.5. What is the probability of A intersection B? 0.32. So it is going to be 1.3 minus 0.32. So how much is it?
0.98.
0.98.
Sir, 0.98. Yes.
0.98. Okay. Right. Next. Evaluate probability of A union B. 2 times probability of A is equal to probability of B is equal to 5 by 3. Sorry, had a power cut. So what were we discussing? This problem, no?
Fourth question.
Fourth one, no? So what is the answer? Solution.
11.
So probability of A given B is equal to probability of A intersection B divided by
Sir.
Tell me that.
Sir, your screen is too small, sir.
Okay, 1 minute. Better, no?
So no, sir. It's yes, sir.
sir.
Now it's better.
Yeah. So 2 by 5 is equal to. So what is the probability of A intersection B that we need to find? Divided by probability of B is going to be 5 by 13. Cancel this and this. So which implies probability of A intersection B is going to be equal to 2 divided by 13. So what is the probability of A union B? It is probability of A plus probability of B plus, sorry, minus probability of A intersection B. See, since the probability of A intersection B didn't come out to be 0, I know that they are not mutually exclusive events. So probability of A is 5 by 26 plus probability of, actually I can write it as 3 times probability of A, no? Okay, I'll write it like this. 5 by 26 plus 5 by 13 minus probability of A intersection B is 2 by 13. So 5 plus 10 minus 4 divided by 26. So 15 minus 4 is 11 divided by 26 should be the answer. So check if this is the answer. Those who have textbook, please check it.
Yes, sir.
Correct? 11/26. Let's do the next one. Solution. If probability of A is 6/11 and probability of B is 5/11 and probability of A union B is 7/11, find probability of A intersection B. So we will consider probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So 7/11 is equal to 6/11 plus 5/11 minus probability of A intersection B, which implies probability of A intersection B is equal to 11 minus 7, that is 4 divided by 11. Correct?
Yes, sir.
What is the probability of A given B? It is probability of A intersection B divided by probability of B. So what is the probability of A intersection B? That is 4/11 divided by probability of B is 5/11. Cancel them. Answer will be 4/5. What is the probability of B given A? Probability of A intersection B divided by probability of A. So 4/11 divided by what is the probability of A? That will be 6/11. Cancel them. It will be 4/6 or 2/3. Okay. A coin is tossed 3 times where E head on third toss. F stands for head on first 2 tosses. So for problem 6 to 9, we need to find probability of E given F. So shall we start?
Yes, sir.
Tell me how to solve. So what is the probability of E given F? That is probability of E intersection F divided by probability of F. So how do I write it, guys? So the sample space, 3 coins are tossed means S will be equal to head, head, head. Right? How can do head, head, tail, head, tail, head. Tell me how to proceed. E is head on third toss. Head on third toss. So what is the event E for the first one? Head, 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 comma,
Sir, 2 more for this one, please. Yes.
8 danada.
Yes, sir. Yes, sir.
2 power 3 la 8. So head, 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 tail, head, அடுத்தது tail head. So what is the probability? So F வந்து head on first two tosses. So you want head only on the first two tosses. So what should I do? Should I take the head into consideration? Yes. And head, tail also into consideration because they didn't mention anything about the third toss. Now tell me, what is the probability of E intersection F?
1/8.
Only one is common, no? 1/8 divided by probability of F is
1/4.
probability of F da 2/4 la 1/4 so 2/8 la.
That's 1/4.
Oh, sorry, Dad. Sorry. There was some other thought. So 1/2. Probability of E intersection F divided by probability of F. அதே மாதிரி second one. At least two heads. At least two heads. Now what should I write? Head, tail. Head, sorry. Head, tail. Head, tail. Head, tail, tail, head. Correct? அதே மாதிரி F எவ்வளோ? At most two heads. At most two heads என்ன எடுக்கணும்? Head, tail. Head, tail, tail, head. That's it. இப்போ சொல்லுங்க, what is the probability of E intersection F? So probability of E intersection F is head, tail, head, tail, head, tail, head, tail, tail, head. So 3 out of 8. Probability of F
3/8.
illa. There is a mistake in what I wrote. Tell me, what is it? There is a mistake in F. They told at most two heads, means minimum can be 0 heads also.
Yes, sir. Tail.
So at most two heads now, there are, except head, I can write everything. Correct?
Yes, sir.
Head, tail, head, tail, head, head, tail, tail, head, tail, head, and tail. So probability of F on the 7/8. So what is the probability of E given F? That will be 3/7. Correct? So tell me the answer for the third one.
Sir, 1 na sir answer.
Anna, how did you write? So what is E? Can I give set?
E, except tail எல்லாமே வரும் sir.
அப்ப 7/8 வருமா? E ல வந்து 7 elements இருக்குடா. Okay. F at least one tail. At least one tail na அதுலயும் 7 இருக்கும். அப்ப probability of E intersection F ல எத்தனை இருக்கும்? Head, headum போய்டும், tailum போய்டும். You have 6. So probability of E intersection F is 6/8. Am I right, guys? And what is the probability of F? It is 7 by 8. 1 kadayadu. It is 6 by 7. Akash, check panna.
Yes, sir.
புரியுதா எனக்கு என்ன ஆகுதுன்னு? So you took this 7 and 7 into consideration. That's a mistake. E intersection F பண்ணும்போது you will not have head 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 and tail 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 as a common element. Except those two, everything else will be common. சரியா?
Yes, sir.
Good. So shall we do the next one?
Yes.
Yeah. So 2 coins are tossed once where E tail appears on one coin and F one coin shows head. So I need to find the probability of E given F. So 2 coins are tossed. Now what are the outcomes? Head head, head tail, tail head, tail tail. Okay. Probability of E given F is probability of E intersection F by probability of F. The first case, what is the value of E? Tail appears on one coin. Meaning, what are the elements I should take?
Head, tail,
tail.
tail.
Next one. That's what they told. No, tail appears on one coin. F1, the one coin shows head. So head tail, tail head. Correct? So what is E intersection F? It is head tail, tail head only. So what is the probability of E intersection F? 1 by 2. Actually, I know 2 by 4. So 1 by 2 divided by what is the probability of F? That is also 2 by 4, which is going to be 1 by 2. Here it is 1. Means it is 100% probability. So what are these kind of events called as? They are called as sure events. Am I right?
Yes, sir.
Second, no tail appears. So E enna irukum? No tail appears means only head head. F enna irukum? No head appears means it is only tail tail. So what is the probability of this kind of an event? Probability of E intersection F divided by probability of F. So answer will be 0. Right? Because there is no intersection at all. So these kind of events are called mutually exclusive events. Am I right? Or you can also call them as impossible events. Shall I proceed? A die is thrown 3 times. E, 4 appears on the third toss. 4 appears on the third toss. 6 and 5 appears respectively on the first 2 tosses. So die is thrown 3 times. So sample space has 216 elements. All are triplets. So E la what should I write? 4 appears on the third toss. So 1 1 4 1 2 4 1 3 4 1 4 4 1 6 4. Similarly 2 1 4 2 2 4 so on till 2 6 4. And here how much will it go? It will go till 6 1 4 and this side it will go till 6 6 4. Correct? So how many elements will you have? 36 elements. What about F? F 6 and 5 appears respectively on the first 2 tosses. So 6 comma 5 comma 1, then 6 comma 5 comma 2, 6 comma 5 comma 3, 6 5 4, 6 5 5 and 6 5 6. So what is the probability of E intersection F? How many elements are common in both? It is only 6 5 4. So it is 1 out of how much? 1 out of 216. What is the probability of F? 1 2 3 4 5 6. It is 6 out of 216. So what is the probability of E given F? It will be 1 out of 6. Am I right? So check the answer once. Is it 1/6?
Yes, sir.
Okay. So shall we do the next one? Listen. Ninth one. Mother, father, and son line up at random for a family picture. E is son on one end, F father in the middle. So, how will the sample space look like? Mother, father, son, mother, son, father. Similarly, if I played son first, son, mother, father, son, father, mother. Then if I place father first, father, son, mother, father, mother, son. Right. E is what? Son on the first end. So these two will come. SMF and SFM. What is F? Father in the middle. Father in the middle, now what will come? MFS,
Sir,
SF. Ah,
E வந்து
சொல்றேன்.
sun on one இருக்குது. So
Sun
அப்ப
on
ரெண்டு
one
end
end. Oh, sorry. Sun on one end. I didn't see in the first. I thought it's on first end. So sun, it can be on the other end also, no? Son, mother, father, son, father, mother, mother, father, son, father, mother, son. Correct?
Yes, sir.
If a probability of E given F, I want probability of E intersection F divided by probability of F. So what is the probability of E intersection F? So what is common? Mother, father, son?
1/3.
1/3, yeah? Every 2 out of 6, 2 out of 6 divided by, what is the probability of F? What is the probability of F? Adu 2/6, 2 elements out of the 6 elements. Answer will be 1. Purida. Check if it is 1. Akash, answer 1 ada. So remaining problems, can you guys try? How many more are there? 7 more problems. Can you guys try it later?
Yes, sir.
So I need to start the multiplication theorem. Based on multiplication theorem only, you will be able to understand base theorem. Okay. I think you have Bernoulli's theorem also this year.
Sir, no, sir.
Yes, sir.
Not there. 1 minute, let
No,
me
sir.
check. Okay, then it's fine. So you have this one, right? Bayes theorem is there.
Yes, sir.
Wait. Statistics. Bayes theorem. Look at a random. You have random variable. Sorry, you don't have Bernoulli's trial. You have random variable and probability distribution. They removed it last year. We had it only till Bayes theorem. So you have random variable and its probability distribution. Mean of random variable. Not a big deal. We'll complete it. Don't worry. Okay. So any other doubt?
No, sir.
Okay. See, if at all a class is needed, can we have it on Sunday or something? Will it work? Because I can pull it off at a stretch. Can we? Yes or no? I need a response.
No, sir, I have another class on Sunday.
You have another class, sir. What time you have?
So from 9 to 1.
9 to 1. Okay. Okay. Let's see. Okay, then we'll wind up.
Thank you, sir.
Yeah.